This webinar, I endeavor to empower techies. We believe that sharing this knowledge is the key of enhancing the performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a quick insight of various domains. Topic for today's webinar is Service-Oriented Integration, Approaches and Best Practices. We are delighted to have Mr. Tapan Verma, Senior Consultant, Software Services at IBM India Limited as our guest speaker today. Mr. Tapan is Certified IT Architect at IBM Software Lab Services for WebSphere in India. He has more than 11 years of enormous experience in the IT industry, 10 of those years working with IBM Software Group. His areas of expertise include SOI and BPM products. Tapan has been working on IT projects as lead architect and solutions using IBM products. Gentlemen, this presentation will continue for next 45 minutes and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Tapan.
Thank you. Good afternoon, everybody, and thanks for joining in. Today's session is about service-oriented integration, SOI. And in this session, we will talk about the different approaches that can be used for integrating different systems using the service orientation. We will talk about various best practices for how to achieve a good integration using the concepts of services and services-oriented architecture. Now, this presentation is, although it says that the best practices are in the heading, you will notice that there is no one single slide which has 4 or 5 best practices listed. In a way, this entire deck is about the right thing to do when you are trying to use services for integrating systems. Also, I would like to set the expectations in the beginning itself. This is not a very advanced discussion on this topic, and so as to accommodate the listeners who are new to this kind of technique. We will start with the basics of what is service-oriented integration, the important ingredients of SOI, and towards the end we will have some advanced concepts mentioned as part of the best practices and the approaches. Okay, now as the name suggests, service-oriented integration is about integrating various systems by using the concept of services. Now, the people who are known to the concepts of integration are aware that when we are trying to integrate some systems, we use some mechanism of interacting with those systems. Some of these systems have some information which is needed by others, some of these systemicity which has to be executed, and we try to find ways to interact with those systems and make them participate in the entire integrated framework. So in this presentation, we will discuss how we can use the concepts of service-oriented architecture to make those systems participate in the integration framework. And that is why, if you look at the agenda, the first topic that we will discuss is about service-oriented architecture, or SOA. An important part of SOA is services, and services is the main concept in service-oriented architecture. And in service-oriented architecture, we develop applications by combining services. And when we talk about services, services have certain characteristics, and web services are one of the best ways that we have at this point of time to define services. Web services follow most of the characteristics that a good service is supposed to have. Okay, we'll talk about it in more detail when we get to that point. Next, we will talk about the enterprise service bus, a very important concept of service-oriented architecture. And enterprise service bus provides us the framework necessary for the service-oriented integration. And then after understanding the basic concepts, we'll jump into the concept of service-oriented integration. And there we'll see how we combine the concepts and the features of a service-oriented architecture, utilize the framework provided by the enterprise service bus for integrating various disparate systems. Once we have understood what SOI is, then we look at the different approaches, which are different techniques which are available to us to make various systems, source system, target systems, provider systems, consumer systems, variety of systems participate in the service-oriented framework. And then after understanding how we can make these systems participate, we'll look at some examples, some commonly used scenarios for integration. For example, how do we integrate two systems if the integration has to happen every morning at 9 o'clock, or the information exchange has to happen every morning at 9 o'clock. Okay, so there are 5 or 6 scenarios that we have covered, and in these scenarios, we will kind of revisit all the concepts that we had discussed by then. Towards the end, we will discuss the differences between the traditional integration approaches like point-to-point or EAI versus what SOI has to offer. Moving on, the first thing is the concept of service-oriented architecture. As many of us know, it's an architecture where we use services, and by combining these services in different orders and different sequences, we develop new applications. Service-oriented architecture provides us ways for defining services in a standard way. It is service-oriented architecture. It's a flexible architecture which encourages the collection of services. In other words, when you develop applications using service-oriented architecture, you end up having multiple services with you. And then developing new application becomes easier and less expensive and less time-consuming, because you don't have to start from scratch. You have some of the artifacts already available to you. It also makes different technologies talk to each other. So different platforms, different programming languages can interact with each other using the principles defined in service-oriented architecture. If you think about it, it's not entirely new technology or a new architecture altogether. I mean, concepts like reusability, loose coupling, they're not new. And in a way, it is just a way to ensure that we follow best practices that we have been following all along for application development. The next concept is the concept of service. So in a service-oriented architecture, service is the most important and the most basic building block. If you look at the picture below, you can see on the right-hand side, we have a service provider. It is kind of a system which has some important business functionality which it is exposing, and on the left-hand side, we have a service consumer or service requester, somebody who is interested in calling that service, or somebody who is interested in getting the information provided by the service. Some of the examples of service, for example, validate address, a small service which can help me validate the address that I have, or complete order. Complete order, it's a distinct business function, as you can imagine, and it performs something that it is expected to do and performed within an application. Services are typically software assets. They're kind of, for example, piece of code or some application which is already built, a prepackaged out-of-the-box application, and these kind of prepackaged out-of-the-box applications can also expose services. One of the important aspects of a service is that it has a very strict, explicit interface. The interface of service is the definition of the service, which describes what is the name of the service, what should be the input parameters to that service, and if I provide those input parameters and call the service, what is that I should expect in return when we call the service, and so on. Interface is a very important aspect here, and it is supposed to be technology independent or platform neutral. Okay. We have to find a way to make sure that these interfaces are not limited to one set of applications or one set of technology. It is important because the interface provides the contract between the service provider and the service requester. It is an agreement that what a service should provide and how it is expected to behave. We'll take a look at some of the examples of the services. One of the examples is fetch customer details. And in this case, the source system or the system that has the information will expose this service. Name of the service is fetch customer details, and as the name suggests, this service will help us fetch or get the details about the customer from a system. On the left-hand side, we have the target system, and the target system is the consumer of the information. And in this case, the target system is the system that requires the customer details, and that is why it is invoking the service exposed by the source system. Another example is the validate address. So the system on the right side is exposing this service. The system has some capabilities which can help us validate the address. Now, as you can imagine, when you call this service, you would have to provide the address as part of the input parameters. And in the response, you would typically get a confirmation whether the address is valid or invalid. Another example is complete order. Complete order is again some kind of functionality which is available in the right side provider application, and the requester is entrusted in invocation of this functionality. Now you can notice that we have used different names for the application on the right side. Sometimes we call them source system, sometimes we call them provider, which is okay, because if there is some information that is available in the system that is entrusted, that other systems are interested in, it's a source system. It is a system which has the data. And if the system has some functionality which has to be executed, then it's actually the provider of the service implementation, and others will call it. Similarly, if you notice on the left side, we have different names. We call them target or consumer or requester. And depending upon the context, these names are applicable. So if the information is needed by an application and it is coming from the source, then that system becomes the target. If you are interested in calling a functionality which is available in the provider, then you are consumer or a requester. Okay. So we will use these terms interchangeably in the next few slides. Those of you who have integration experience would notice that these requirements are not too different from the typical integration scenarios that we have. Look at the first example. It looks like there are two systems. One system has some information which is needed by the second system. So it's an integration requirement. Okay, and we are trying to give it a service touch. We are trying to make the system more service oriented to get this done. Similarly, in the second example, one system has some functionality, and this functionality has to be executed. It has to be performed in the right-hand side system, and the execution of that functionality should be triggered by the system on the left. Again, another typical integration scenario that you will see. So in other words, when we try to make these systems participate in the service orientation by exposing something as web service or calling the web service exposed by other, in a way we are trying to solve some of the integration problems. Now that we have understood what a service is, let's talk about a specific type of implementation of service, and that type is the web service. Now, in this entire presentation, we can actually go through the entire deck without mentioning the web service also, because we are not talking about how to use web services and the best practices of web services. However, the web services are one of the best ways, one of the best techniques for exposing services. And when we say one of the best techniques, what I mean to say is that the services exposed using web services mechanism follow most of the design principles of a good practice. For example, web services are platform neutral. They are language independent. It doesn't matter whether the service implementation is written in C++ or Java or .NET. People outside can call it, irrespective of which technology they use. Similarly, a good service is expected to have a strict interface, a strict definition. In web services world, we have WSDL, which stands for Web Services Description Language. And it's a very strict language for defining what a service can do. So using WSDL, I can define the name of the service, I can define input parameters, I can define output parameters, I can define their data types, and so on. And WSDL itself is not a proprietary technique, or it is not a technique which is limited to one set of technology. It's an open industry standard, and it uses other standards like XML and XSD. Web services help us with the concept of hiding the internal lower level implementation in detail and expose platform independent and the technology neutral way of exposing the capabilities of a system. Web services are also loosely coupled, which means that between the web services, we can define that there is no dependency or no state management if that is the requirement. Now, although we use the term web services, it doesn't mean that it has to be on the web, or it has to be over internet, or it has to use something like HTTP. We can have other transport protocols, for example, JMS. Those who do not know what JMS is, it's a messaging protocol where we use queues and topics for exchanging information. Now, I would like to mention that although I'm using the term web services here, or in fact in the remaining of the slide, I will be using the concept of web services extensively, it does not mean that SOI is all about web services. It also does not mean that if you are using web services, you have all the benefits of a service-oriented architecture. In other words, you can use web services and end up with a really bad services-oriented architecture or services-oriented integration. And also, on the other hand, you can use some other way of exposing services, not by web services means, and still have a very good service-oriented architecture or service-oriented integration. Okay. So, like I said, web services is not the only technique. I mean, we can use REST interfaces, we can use XML over NQ, and so on. As long as you follow the principles of good service, you should be able to implement service-oriented architecture and service-oriented integration correctly. The next very important concept is enterprise service bus. I will let the screen refresh. Okay, it is taking time. Anyway, the enterprise service bus, yeah, there it is. The enterprise service bus, if you look at the picture, we have a requester, service requester or service consumer on the left-hand side, and on the right-hand side we have a service provider on the system which is exposing its capabilities as services. And in the middle we have the enterprise service bus. Enterprise service bus here is mediating the messages that are flowing between the service consumer and the service provider. And ESB is capable of mediating both request as well as response messages. But why do you want to mediate these messages? But once mediated, the ESB can do something about those messages. It can read out those messages if required. It can help you with conversion of transport protocols. And what does that mean? Well, let's say the provider system or the source system on the right hand side is based on SOAP over HTTP technology, and the system on the left side does not know that technology, and system on the left side can only understand XML over JMS. So as you can see, one system knows only HTTP, other system knows only JMS. The enterprise service bus in between can help us bridge that transport protocol gap. Similarly, if there is a gap between the messaging formats, for example, one system handles XML and the other system expects CSV formats, then that kind of transformation can also be done using a standard enterprise service bus. Another important feature of enterprise service bus is to handle events. I will park this topic here for the time being about the business events, and I'll get to it in the next slide. But at very short, the events are something happening in one of the systems, and this information about the event is there are other systems who are interested about those events happening in one application, and those kind of events can be handled at the ESB level. And how that happens, we'll see in a bit. ESB can also help you enrich the message. So message that comes from the source sometimes lacks the completeness. Sometimes it requires additional information to be added to the message before it reaches the target. And the enrichment of message can also be done by enterprise service bus. Enterprise service bus can actually get the data from multiple source systems, combine the message, and deliver it to target. And if you notice, these are typical integration requirements also. Enterprise service bus can optionally validate the message. So for example, the message that comes from source, we want to make sure that one of the fields is not null always. So that kind of validation can be done in enterprise service bus before the data is sent to the target system. We'll get to the event notification a little later. So with all these capabilities, the enterprise service bus provides us the integration framework, which is the backbone for service-oriented integration. And it provides us capabilities to make source systems and target system and service requester and service providers and event emitters and event subscribers, the variety of system types, participate in the service-oriented integration. There are various products available in the market which provides the enterprise service bus capabilities. To begin with, enterprise service bus is a design principle, and this design principle is an important principle in service-oriented architecture. And then all these products from IBM, for example, IBM's WebSphere Enterprise Service Bus, J2EE based enterprise service bus, and very good in handling the expectations which are mentioned on this slide deck. Then there's IBM WebSphere Message Broker, which is good when you have lots of messages and your integration and your message mediations are primarily messaging driven. Then there's a hardware-based enterprise service bus called IBM WebSphere Data Power, and it's good when you have a lot of XML processing, a lot of security context that has to be exchanged between applications and the enterprise integration. Apart from IBM, there are other enterprise service bus products available from other companies like Microsoft, Oracle, and TIBCO. On the next slide, slide number 8, you can see that there is a nice picture of enterprise service bus. I've taken this picture from IBM's WebSphere Enterprise Service Bus Info Center, which is available on the web. And as you can see in this picture, we are trying to make different systems talk to each other. And the shape tells shape and color tell us the message format and the protocol. So the message that comes from the blue circle could mean SOAP over HTTP. and the message that goes to green triangle could mean XML over NQ. So you can see the enterprise service bus can not only do the transport protocol conversion, but also the message format conversion. There's one aspect that we have not discussed in detail is the event handling. Various source system and target systems can also participate in service orientation by sending different events information to the enterprise service bus, and also subscribing to the different events which are available to enterprise service bus. And it can happen in different scenarios. For example, the requester application, the application which requires the information, it can send an event to the enterprise service bus informing enterprise service bus that it is ready to consume the data. Similarly, the provider application can send notification to enterprise service bus informing that it is ready to provide the data. An example could be, let's say a provider system is the order processing system, and in this system, whenever a new order is completed, the provider system wants to inform the rest of the world that order is complete, and if anybody is interested in knowing about that order in more detail, they can come and ask for it. But only provider system knows about it. So in many ways, it is the responsibility of the provider system to let the rest of the world know about the completion of order. And that can be done by making the provider system send an event to the enterprise service bus. What are the different ways of sending events? Well, that could be a web service call, that could be putting a message in a queue, that could be even putting a file in a folder. So there are different technology ways of generating the event. We'll talk about some of these ways in the following slides. Okay, the next important concept is about the mediation flow. The mediation flow is the flow of the message as it is in the enterprise service bus. As you can see on this slide number 9, there is a system on the right hand side which is a provider, and the system on the left hand side which is the requester. In simple words, information has to go from A to B. A has some data, B wants it, and we are going to make sure that it happens by putting an enterprise service bus in between. And what is the advantage of putting enterprise service bus in between? Well, as discussed earlier, it can bridge variety of gaps in between. The gap about the transport protocol, the gap about the message format. Even if the message lacks the completeness, it can do the enrichment of message and so on. And we do that by using what is called the primitives. Now, in the enterprise service bus, we define one or more mediation flows. And these mediation flows are actually the flow of message from source to target and back from target to source. We can call them request message flow and the response message flow also. And as part of this message flow, there could be different primitives that can be used in enterprise service bus. And these primitives can help us, routing or the transformation or the message enrichment as discussed earlier. They can also provide a different kind of lookup. For example, I get some data, but the rest of the data is available in some database. So we could use some database lookup primitive to fetch the information. Some of these symbols that you see on the screen, I have taken from IBM WebSphere Enterprise Service Bus because I had access to that product. But most of the concepts that we are discussing in this presentation apply to most of the good ESBs available in the market. And as you can see, there is a flow. The requester would actually invoke the mediation flow rather than invoking the provider. And as part of it, the request message will flow through the mediation flow via all these primitives, and the message will be filtered, enriched, it will be transformed, and so on. And then the message goes to the application on the right-hand side, application A. Similarly, when the application A responds back, the response flows through the response flow of the mediation flow. And as part of that, there could be other set of primitives that can be used for transforming and enriching the message before it is delivered to the requester, application B. The important thing to note here is that the mediation flow itself can be exposed as service. Okay, so in other words, B, instead of calling A application service, is actually going to call ESB, or in other words, B is going to call the service exposed by the mediation flow. Okay, and the benefit is that the mediation flow can bridge all the gaps between B and A before getting the data from the application A. Okay, so now at this point of time, we understand that service-oriented architecture is an important concept for SOI. We also talked about the different kind of services that we have. We also understand that services have certain characteristics. They are supposed to be loosely coupled, strictly defined, and so on. We have discussed the enterprise service bus as one of the important aspects of achieving service-oriented integration. And we have discussed the mediation flow. And the mediation flow is what drives the flow of message from one application to other application. So by combining all these concepts, we can define service-oriented integration as a way to integrate applications by using services. In service-oriented integration, we make different systems, source system, target system, information provider systems, service-oriented. So when we say we make them service-oriented, it means that we use some techniques to either expose their capabilities as service or make them participate in the integration framework by making them call some of the services. Like you saw in the previous slide, the application B was calling the web service exposed by the enterprise service bus. And enterprise service bus itself is providing all the integration framework, and this framework has a lot of capabilities. Some of the capabilities we have discussed already, and other capabilities we'll see in the upcoming slides. We use the terms source and target system, very commonly here, and you know that the source systems or the provider systems would have some information that is needed by the target, or they have some functionality that needs to be executed. And the next important concept was about the events. And there are some systems that generate events. There are some systems that subscribe to those events. At the bottom of this slide, you can see there are two pictures. The picture on the right side is a blue color web cloud, and this is what I will be using for defining web services or depicting web services, this blue color cloud. On the left, you can see a gray color arrow, shaded arrow, and this is what I will use for depicting the web services clients or the web services consumer, people who would typically call the web service. Okay, now in this slide, we will try to make source system and target system participate in this service-oriented architecture. We will try to make them service-oriented, if you will. And how do we do that? Well, there are different techniques that we can use. On this slide, you can see the list of some of the common techniques that can be used to do that. And in the next few slides, each one of these techniques will be explained in more detail with some picture, with some animation, and so on. And so at the top, we have the service provider, which is, let's say, the source of information. And how do I make this kind of system participate? Well, we can expose the capability of this system as web service so that people outside can call this web service and fetch the data. We can also make them push the data out by making them call the web service which is available outside. And there are different scenarios when you want to do that. And we'll talk about those scenarios in more detail later on. The second is the target system. The target system is the system where the data has to go. or the consumer, who is actually consuming the information. Now, this kind of system can expose web service for receiving the information. This is like more passive approach, where they expose the web service and they rely on somebody outside to push the data towards them. And the second approach could be, more active approach, more aggressive approach, where you go and get the information from wherever it is available. So you request for data by calling a web service available outside, the web service that can provide with information. And then about the events, the source system can publish events, and the other system can also publish events. Earlier, the source system would typically publish the event about the availability of the data. Or, for example, if something interesting happens in the source system, for example, the order is completed, or a new customer record is created. So some information is available, and something important, something interesting that other people might be interested in. Similarly, target systems, whenever they want something, they can also publish an event specifying that they are ready to consume, and so on. Okay, moving on. Now, in the next few slides, as I said, we will discuss some of these approaches in more detail with more pictures and animation. And I noticed that there is some lag in slide refresh. So let me just get rid of some of the animation and make sure that it's visible to all of you. Okay, in this case, we will see how to make one of the source system participate in the SOI. And the approach here used is to expose the capabilities of the source system as web service. And this is more of a passive approach. We have an application A. This application A has some data or some functionality that others are interested in. And we will make this functionality exposed as web service. Once it is exposed as web service, the people outside can call it. The people outside, who are typically the web service clients or web service consumers, can call this web service and pull the data. Okay. One of the possibility is that it is the ESB which is on the left-hand side calling the web service and pulling the data. So the web service client or the ESB would send the request to this provider by calling the web service of the provider, and as part of the response, they get what they were looking for, the entire data. The next scenario is the second case for the source system, in which case the source system, the system which has the data, is not exposing a service for others to call, but it is calling a web service and pushing the data out. So you see, we have a service, we have a provider, application A. Again, it has some data that other people are interested in, and it is going to push this data out by calling the web service available outside. And that web service could be provided by either the consumer of the information, which is like the target, or the enterprise service bus. So this system will push the data by calling the outgoing web service, and as part of the request, as part of the service call, the entire data payload is also there. This kind of scenario is commonly used when the provider system is the best system that knows when the data is ready for consumption. So like I said earlier, order complete. When the order is complete, that's when the information should be pulled out, not before that. Okay, so in that case, it is advisable to make the target system publish this information to the people who are interested. Now, rather than sending this information to one of the consumers, we would typically make these targets, these source systems, give the information to enterprise service bus. And the benefit of giving it to enterprise service bus is because enterprise service bus can distribute this data to all the people who are interested in. I mean, they can subscribe to it, and they will get this information when it is made available to the enterprise service bus. Okay, the next two slides we'll talk about the target system and how do we make target system participate in the service-oriented integration. The target system is a system in need, and they are the people who are looking for the information, and the information has to come from source. Okay, so it's again A to B. A is the provider, B is the consumer or receiver. So we're talking about system B here, which is in need of the information. So first approach is more of a passive approach, where you expose the functionality of consuming data as web service. So in this case, you need some information, and you have the placeholder, where you can store that information, but that information will be pushed in by somebody outside. So in that case, somebody outside will call your web service and push the data along with it. And as part of the incoming call, all the data is going to be also there as the payload. And there could be an optional response also, telling the provider thank you, or whatever, we have received the data successfully, and so on. Or it could be just one-way push. The next approach for the target system is like I said, more active approach. You're not sitting back and waiting for someone to give you the data, but you go and get the data yourself. You request for it when you need it. So in this case, again, system B is the target or consumer. It requires some information which is available outside, so it's going to ask for it by calling the web service which will give the information. And this web service could be exposed by the service provider or the enterprise service bus. As you can see, as part of the request, it is just a request for getting the data, and as part of the response, you have all the data that you were looking for. Next slide, slide number 16, is about the event notifications. And we have discussed this earlier. Both source system and target system, or you may call them consumer system or provider system, can participate in generating these events. And these systems can also subscribe to the events. And how do we do that? Well, how do we notify the enterprise service bus that something interesting has happened? Well, one of the ways is by calling the web service. If you remember earlier, when you saw the mediation flow in the enterprise service bus, we discussed the enterprise service, the mediation flow can also be exposed as a web service. So my source system or my target system can call that web service and tell enterprise service bus that something interesting has happened. And the enterprise service bus can take that responsibility of informing the people who are interested, the other subscribers. One of the aspects of events is that in case of events, you may not have the data, you may not have the payload with you. It's just a notification that, yes, I'm ready, or yes, the information is available. And then there will be another call, and that other call will actually go and get the data. All right, so now that we have discussed the various approaches of how to make different systems participate in this service orientation, we talk about some of the integration scenarios. These integration scenarios are some examples of how we make it all work. Now, scenario one, it's a very straightforward scenario. Information has to go from A to B. A is the source, B is the target. And if you look at the picture, A is actually pushing the data. A is calling the web service, and it's clear by the symbol that I'm using. The symbol is the gray arrow, which is used for detecting the web service call. Okay, so it's going to call the web service and push the data out. And in case of B, if you notice, we have a web service, and this web service is basically to push the data in the B system. So from A, it's outgoing, and from B, it's incoming. And as part of the entire flow, A is going to call the mediation flow. Once again, I would like to remind you that the mediation flow itself is exposed as a service. A is pushing the data to mediation flow, and now the data is there in the mediation flow. The next step in the mediation flow is to do something about it. For example, do some kind of transformation if needed, some kind of message format conversion or transport protocol conversion and so on. And once it is ready for the system B's consumption, the third step is to push it in system B by calling the web service of system B. So once again, A is calling the web service of mediation flow and pushing the data in mediation flow. And step number 3 is calling the web service of target B and pushing it in the target application. The second scenario, in this case, we have a scheduled interval for integrating two applications. I mean, application, once again, data has to go from A to B. Application A has the data, it has to go to B, but it has to go not when A pushes it. It has to go every morning at 9 o'clock. Okay, so in this case, once again, we have application A and application B. A is the source, B is the target. And if you notice, in this case, A is not calling the web service because A is not actively participating. It's there in passive manner. It is there. It has exposed the web service for someone to come and get the data. Similarly, B has exposed the web service for someone to push the data in. As part of a typical enterprise service bus, the integration framework, you would have some kind of the scheduling capability. Like IBM's WebSphere Enterprise Service Bus has a scheduler which can kickstart the mediation flow at regular intervals. So in this case, we will use the scheduling capability of our ESB framework, and we'll kickstart this mediation flow by calling the web service of mediation flow. Once it is called, then mediation flow will, step number 1, fetch the data from source by calling the web service. Once it has the data, it will apply some transformations which are required, and then step 3, it will push this data in application B by calling the web service of application B. So pull from A and push into B, and in both cases by executing the web service. Slide number 19, integration scenario 3. Well, in this case, consumer wants the data and consumer is going to request for it. I mean, he's the guy who is in need, so he's going to ask for it. Once again, we have A and B. A is the provider, B is the consumer. And as you can see, in this case, B is in a mode where it is going to call the service, and A is in a mode where it's going to expose the web service for someone to come and get the data. So as part of the flow, the enterprise service bus has a mediation flow. Step 1, consumer or B will call the web service of mediation flow and request for the information. Step 2, in the mediation flow, it will do some kind of transformation if needed. For example, the request message is not in the correct format, so it will do the format conversion. And then step number 3, fetch the data from provider application A, and then there is a response flow. The data comes back. Step number 3. Step number 4, as part of response also, if some kind of transformation is required, that will be done, and then back to application B, consumer. So it's a typical request response flow where the request is initiated by B and it is fulfilled by A, the provider. Now you might ask the question, why can't B directly call A? Why to go through this entire loop? Well, if you see step number 2 and step number 4, they're playing an important role here. In this case, B could not directly call A because there were, as I said earlier, gaps in between. There were a transport protocol gap, message format gap, security context gap, the semantical gaps between the message that goes from A to B, for B to understand it. And all those kind of gaps will be fulfilled by the enterprise service bus in between. The last scenario is scenario 4, where the information has to go from source to target. In this case, source system emits an event about the availability. Once again, my favorite example, the order is completed and now the information can be exchanged, the information can be sent to others. So application A is a source, B is a target. If you notice, with A, we have two things. We have an event notification that goes out and a web service that exposes the fetching of this information. Step 1, the source application will publish an event, and it will do that by calling the web service of Mediation Flow. And as part of this event, it will simply inform that the information is ready, or the order is complete, or the new customer is created. Step number 2, then Mediation Flow will go and fetch the data. So I would like to remind you once again that as part of the notification, there may not be any payload, or there may not be any full-fledged data about the customer or the order and so on. So that's why step number 2 is required, where the required web service will be called and the data will be fetched. Step number 3, once we have the data, then required transformations will be done in the Mediation Flow by applying the necessary primitives like Lookup and so on. And once the transformation is done, then the data is pushed into application B, the target, by calling the web service of application B. So those are the very 4 common integration scenario, and we have seen how we use the service orientation of a source system and target system to participate in the integration. Now, another common thing that we see in use is service lookup. And in this case, well, we have the data, and it has to go to one or more target applications, and source is pushing the data. So as you can see, there is one source A, and there are 2 targets, B1 and B2. And source is going to push the information, and my middleware, my enterprise service bus, my integration framework has to decide whether information has to be delivered to B1 or B2. It also has to find out the location of B1 and B2, which is the address where to find the target. So in this case, once again, we have an enterprise service bus, and inside the bus we have the mediation flow. The source system is pushing the data by calling the web service of mediation flow. Once the data is there in mediation flow, step number 2 is to apply necessary transformation, and now you will see the change. You see step number 3? Step number 3 is a call to service registry, and in this case we are using our service registry to look up for the information needed for the 4th step. Step 4 is the delivery, but before that I need to know whom should I deliver the information to, and where to find that person. Okay, all that can be fetched from service registry. We can also define some policies where we can say, well, if it is a high value order, it has to go to B1, otherwise it has to go to B1, or we can make it time based. If it is the month of January and February, it has to go to B1, for rest of the months it has to go to B2, or if it is our gold customer, it has to go to B1. For all other customers, it has to go to B2. Why B1? Because B1 service implementation is running on a better hardware, better infrastructure, and it can have a better service level agreement, better response time, and so on. So we can do all that by introducing this service lookup and the service registry. You could use a service registry. One second. Okay. Step number 4 is where we push the data to the desired application. So in step number 3, we decided which application to push the data to, and step number 4 delivers that by calling the web service of either B1 or B2, or in some cases both, if that is what my service registry tells me, that the information has to go to both of them. Okay, so that's all about, hold on. Keshav, is the screen getting refreshed? Well, I guess it is.
Yeah.
Okay. Now, the next slide is slide number 22. Okay, yeah, I'll continue. Slide number 22 is what are the other things that we can do with the service-oriented integration and the integration framework, which is driven by service-oriented integration powered by Enterprise Service Bus. Well, we can bridge the gap between security contexts. For example, again, data has to go from A to B. A is the provider, B is the consumer. A says, I can only give you data over HTTPS because I am more secure. And B says, I don't know HTTPS. I can only request for it over HTTP. Now, who is going to bridge this gap between HTTPS and HTTP? Well, SOI can do that. Or in other words, ESB can do that. The message level security. A says, I'm expecting SOAP encryption, because I want the high level of security for the data that I'm trying to exchange. B says, I don't know SOAP encryption. In fact, I don't know any encryption. I expect the data in completely unencrypted way. Or I support some different kind of encryption, for example, XML encryption. So in that case, again, there's a gap between what source and target systems can support in terms of the security context. So an Enterprise Service Bus can bridge the gap here. The next is authentication and authorization. A says, if you want to call me, you have to use a specific user ID and password, or you have to use a specific certificate. Okay. Whereas B says, I don't have your user ID and password. I can give you the employee's user ID and password who is working on this application. And A says, you know what, I don't know all the employees in your organization and I don't understand what they can or cannot do. So there's a gap again. So the provider is expecting a specific service account, whereas the requester has some other kind of credentials, which could typically be LDAP based. So these kind of gaps can also be bridged by using correct primitives and the capabilities of a good enterprise service bus. So things like XML encryption versus SOAP encryption can very easily be done with ESB, like the data power. The LDAP-based credential versus service account, again, can be done with data power, message broker, or website enterprise service bus, and so on. The next is the auditing feature. Auditing is when you want to store some more auditing information about the information exchange that happens via this enterprise service bus. And we can do that using some of the ESB primitives, like message logger primitive of WebSphere Enterprise Service Bus. Okay, we are towards the end of the presentation, just 2 or 3 slides left. Let me just see how we are doing in terms of time. Okay. You must be wondering, what happens if there are some systems that don't support web services? I mean, if you have a system which is a very old application or a legacy application or a mainframe application or some of the custom-built application which is not based on this service-oriented mechanism, or it doesn't provide the capabilities of web services. Well, the good news is that the Enterprise Service Bus can help those systems also behave like services. In other words, ESB can make them expose their capabilities as web services, and also on the other side, ESB can make them call the web services by using some additional layers or wrappers. And some of these things are called adapters. In this slide, you can see how an adapter is participating in making my source system service aware. So all my source system can do is generate a file. For example, every time a new order is prepared, my source system will generate a file and put that file in a folder. It doesn't call web services, it doesn't support JMS, doesn't support MQ, doesn't support HTTP, and so on. But this is good enough. As long as the file is available in the folder, I can use this event of getting the file in a folder as the required event for me to invoke my mediation flow. And how do we do that? We can do that by using something called a file adapter. And you get a lot of these adapters as part of standard enterprise service bus products. like as part of Enterprise Service Bus, you get file adapter, you get database adapter, you get email adapter, and so on. And then there are some other adapters, like adapters for SAP, JD Edwards, and some SCM system and CRM systems, and so on. So we are using the file adapter here, and the file adapter is constantly monitoring the folder. And the moment the new file comes to the folder, file adapter knows about it, and it fetches the information about the file and notifies the Enterprise Service Bus by delivering this as an event to the ESB. Optionally, it can also provide the payload, which means the contents of the file. And another option is that it can actually read the content and format the content into what is expected by the Enterprise Service Bus and the subsequent targets. So these adapters know the technologies. For example, file adapters knows how to deal with files and folders. So in this example, you can see file adapter is generating the incoming event, something that is coming in. It can also generate outgoing capabilities. For example, I can use the file adapter on the right side also, where the ESB has to push the information in a file. Why? Because my target system doesn't support web services, and my target system expects the information in a file every day morning at 9 o'clock. So my ESB can do that by using a file adapter and generating an outgoing event. So like I said, there are some adapters available out of the box with some of the Enterprise Service Buses applications, and then there are other adapters that you can get for like SAP, ERP, SCM, and so on. And if you have an application for which there is no adapter available, you can actually create your own custom adapter. Some of these Enterprise Service Bus technologies provide ways for you to develop adapters. And if you don't want to develop an adapter, then you can write a small code which will call the APIs of the source system or the target systems internally and expose that custom code as a web service by using a web service wrapper. So Enterprise Service Bus has those kind of capabilities. So rather than making source system and target system call each other by using their APIs, we make them expose themselves as services and make them participate in the service-oriented integration. There are a few more common practices that we use. Once we have a lot of these services and these systems exposed as services, we can do the service orchestration by using more advanced techniques like business process execution language, or BPEL. And with BPEL, we can actually have the processes or the message flows which are aware of the state also, and which could be very long running. For example, as part of the flow, I tried to push the data into the target system, and it fails because the target system is down. And the requirement is that I have to try after half an hour again. I'm not going to ask the source system to give me the data. I will keep the data, I will persist the data, and I'll try after half an hour. So I can do that using BPEL. Or in case of a failure, you may want a human to take a look at that data before retrying again. So I can add a human task capability as part of my business process execution flow. I can use my Enterprise Service Bus to do some kind of SLA monitoring. For example, my service expects a response time of less than 3 seconds, but whether it is actually delivering the response in 3 seconds or not, how do we know? We can do that by using ESB and some of the primitives of the ESB for SLA monitoring. Data Power does it very well. Other practices is combining multiple sources for preparation of data and giving it to the target, or taking the data from one source and delivering it to multiple targets. Okay, here's the last slide about the SOI, and it's a quick comparison between the three. Very old point-to-point integration approach and versus EAI versus SOI. As you can see, in point-to-point integration, on the left side picture, there are 1, 2, 3, 4, 5, 6, 7, 8 applications trying to talk to each other. And every application has 7 other interfaces built on it. It is very brittle in the sense that if you try to change something, it will have a bigger impact on your solution, and you have to make changes at many places. For example, if the IP address of one service change or one system changes, or the technology changes, or host name changes, it will have major impact. Some of these problems are mitigated in the second option, which is EAI, because in EAI we are using hub and spoke architecture. There's a broker in the middle, and there are these 8 applications available as spokes. And we are using some kind of technique, typically the adapters, to make these applications interact with the hub. And then 2 applications interact with each other via the hub. It is much less brittle than the point-to-point integration. However, with the broker-driven EAI approach, the technique that we use to make these applications connect with the hub are sometimes proprietary. Sometimes we use the adapters which are specific and not based on the open technologies like the web services. And that's where the option third on the right hand side, SOI, is the best option. Here we use the enterprise service bus in between and make these applications expose themselves as web services. And changes that are happening in terms of technology or platform or the programming language will have minimum impact on the architecture that we have defined, as long as there is no change in the signature or the interface, which is in case of web services, WSDL. So finally, we saw that the ESB-driven SOI integration framework provides the different kind of integration capabilities. It has features like loose coupling. It can help us bridge the gap between various systems. These gaps could be transport protocol gap or the message format or the security context gap. It can also help us, add some more value to the message that is going from application A to application B. And this framework is comparatively less brittle than EAI or traditional point-to-point integration. Okay, now if you need some more help on this topic, you can contact IBM WebSphere Lab Services team, and there are SMEs available who can help in terms of training, education, and mentoring. There is an accelerated value program, where you can consume this consume the services of the subject matter experts on these technologies. The IBM WebSphere Lab Services team can also help you in your solution implementation. It can help you with the delivery of the solutions, including the enablement and handover. And one of the ways to kickstart is by engaging the practitioner in a more two-way communication way by conducting various discovery workshops where the WebSphere Lab Services SMEs can help you define the roadmap of IT for your organization. They can help you with defining the best practices, and along with you conduct a quick win pilot followed by the full-fledged implementation. The Center of Excellence offering is where the consultants work with you and build these kind of competences in your organization. So they start with the education and the mentoring, and they work with you with some kind of pilot implementation. And once you are self-sufficient, then provide you the remote mentoring while you work on the full-fledged implementation yourself. There are performance engineering. Sorry about that. There are performance engineering services where the performance workshops can be conducted to detect the performance problem in your IT infrastructure. They can find out the bottlenecks in the end-to-end delivery of information based on the different non-functional requirements that are captured as part of the requirements. They can also assess the capabilities of your system to support the high availability and load balancing. The services are available in terms of assessing the integration maturity of your organization and the health check assessment, where the SMEs can review your architecture, your infrastructure, and comment on it in terms of the maturity of a system. They can inform the best practices of using the ESP-based integration for different industries like banking, telco, and so on. And finally, the migration services, where the SMEs can help you migrate from older versions to the newer version, or from one technology to the other technology, or from one platform to other platform. To know more about these things and get in touch with the WebSphere Lab Services practitioners, here's the email address given. The person's name is Pavan Raval, and you can contact him for any more information that you require. And I guess that's all I had to discuss today, and I leave the forum for questions now. Okay, I can see some questions. Hold on. So the first question is from Vishal, and the question is SOA language independent? Well, that is the expectation. The services that we define in the SOA framework are expected to be programming language independent. If you take an example of web services, when a web service is exposed, it doesn't matter whether the internal implementation is done using Java or C++ or .NET, or for that matter, even if those web services are exposed by some ERP system like SAP. So yes, it is the expectation that the services in SOA are language independent. So the next question is the service referred in this context is same as WCF services? And this question is from Prateek. Okay, now I am not very sure what WCF, but if I were to guess, I think it is some of the Microsoft technology provided as part of their BizTalk framework. Well, like I said, I'm not a WCF expert, but if WCF services are web services in their true sense, then yes, in this session we are referring to them. And I also mentioned that for service-oriented integration, you don't actually have to use web services always. As long as you have some kind of service mechanism which follows all the best practices of service and all the characteristics of service, like loose coupling, like a strict definition, the platform and the technology and the neutral implementation, then I guess you have the services that can be used there. So the next question is, I have heard SOA being used in OSS BSS billing system in telecom domain from my friend. Can we use SOA in banking domain? If so, how? And this question is from Ravindra. Like I said, yes, SOA can be used in variety of domains, and what you have to see is that what kind of systems you want to make participate in the service-oriented integration. And depending upon the frequency of the integration and the message flow and the volume of the messages, you may want to decide on which enterprise service bus you may want to go for. So if you have thousands and thousands of messages that need to be processed very fast, probably a message broker could be a good ESB for that kind of integration. Okay, the next question is from Khalid, and the question is, what is the difference between target, consumer, and the requester in these examples? Well, so when we say the target, in this case, we are referring to a system which is in need of the information, which requires the information that comes from outside. The consumer could also be referred as a target, because in this case, consumer is the consumer system which is consuming the data. Consumer is also used in those scenarios where there is a functionality which is available on the right side, and the consumer has to execute it. For example, validate address. So in this case, I'm not trying to fetch the address detail. I already have those details. I'm just trying to check if the address is valid. So as a consumer of the service, I'm calling the service with all the address detail and let the service provider do all the validation. Okay, next question is, can you please tell us which architecture is the best for using web services, SOA, REST, or XML RPC? Well, and this question is from Preston. if I'm pronouncing the name right. SOA, REST, and an XML over RPC, XML RPC. These are not necessarily directly comparable. SOA in itself is not a transport protocol or a messaging format. SOA is an architecture. It's a set of design principles. For example, use of services. For example, use of services which are loosely coupled, which are platform independent, and so on. REST is a technology. It's a transport protocol over which we can exchange the information. A comparison between REST or XML RPC. Well, XML RPC is typically used for web services. REST is for non-web services, HTTP-based request or response. So, in my experience, REST interfaces are comparatively faster than web services, although they may not have all the features which are available as part of web services. So depending upon the features that you are interested in, you may choose to go for XML RPC or REST. And in both these approaches, if you follow all the best practices and the design principle, well, you have SOA. Okay, the next question is, what are the limitations / disadvantages of SOI? And this question is from Aditya. Well, okay, so yeah, there are some scenarios where you may not want to go for SOI. For example, you saw some scenarios where information has to go from A to B. B is exposing the web service, and A is consuming a web service. So why not make them talk to each other directly? Why put something in between and make this entire flow go through this long route? Well, in some cases you would want to do that, like we discussed earlier. If the message format doesn't match, if the transport protocols don't match, and so on. But there are other cases where you want faster performance. You don't want any kind of lag in between. And typically those scenarios where that there are lesser number of interfaces and the systems need to interact with only each other, and there are no other consumers or the providers going to be in the picture in the long run also. If you know that for sure, then yeah, maybe using SOI it is not one of the good options there. For example, if I'm writing a Java code and if I have 2 Java classes, putting SOI in between those 2 Java classes doesn't make sense. I can make them talk to each other directly, and I can still use some of the best principles like reusability. I mean, as long as I'm within that Java application, I can reuse all the Java classes, and I can follow the loose coupling principles by making sure that the operations of the Java class are perfectly encapsulated. Okay, the next question is from Mohammed, and this question is whether ESB is in our control, or within bracket it says application control. Can you please give an example of how message transforming happens? Well, ESB, if you establish an ESB-driven integration platform, then yes, it's going to be another software, most probably, which you will have to install, and then you will have to make all your message flows go through this enterprise service bus. So rather than making application A talk to application B directly, you will make A talk to ESB and let ESB talk to B. And yes, it is very much in your control. When you say your control, it means that the control of the team which is managing the enterprise service bus. And I would assume that in an organization there would be a dedicated team for managing the enterprise service bus. And by this, this team can handle things like changing the endpoints, changing the addresses of services, or enabling or disabling services, or monitoring the SLA of the service responses, and so on. The second part of this question is, can you please give an example of how message transforming happens? Well, so application A, rather than talking to application B directly, will talk to ESB. And once the message is in ESB, then ESB can take advantage of various capabilities it has in terms of primitives. For example, it has a primitive called XSLT primitive, and here I'm talking about IBM's WebSphere Enterprise Service Bus. And this XSLT primitive can use an incoming XML and apply different kind of transformations, and it can convert it into some other format that is expected by the target. So typically you would do that by creating different mediation flows and deploy those mediation flows in the enterprise service bus. So ESB will provide you the framework. However, the development of the mediation flows will be done by the development team. So the development team will look at system A, it will look at system B, and study their interfaces. It will study their technology gaps in terms of their understanding of the structure.
Hello?
Okay. The next question is to explain how you...
Your voice is not coming, Tapan. Yeah.
My voice is not coming?
Yeah, it's fine now. Please continue. Thank you.
Okay, just 1 second. Let me just see if network is okay. Okay, where were we? Yes, the next question is from Ajay, and this question is, please explain how ESB is important in event notification. For example, in formats. Okay, let me see if I get the question right. How ESB is important in event notification. Okay, let's take a scenario. There's one system which is responsible for order processing, and whenever an order is completed, then there are other systems, let's say system B and system C, who are interested in this information. Now, if there was only one system, probably we could have developed a mediation flow between A and B. But now in this case, there are two systems. A is providing and B and C are the consumers. And in this scenario, B and C have different requirements. They both want order data, but not the same data. System B wants, let's say, all the financial aspects of the order, and system C wants all the customer related information from that order which just got completed. So because there are two different sets of data, you can't have one mediation flow taking care of it. Okay, what you want is multiple mediation flow. However, as part of both these mediation flows should be triggered only when the order is completed. Now, one option is you make system B and system C continuously poll system A and C if there is a new order completed or not. Second option could be you define your event mechanism in such a way that system A informs enterprise service bus that a new order is completed. In that way, once the ESB is aware that the new order is complete, then ESB can trigger two mediation flow. As part of mediation flow 1, the mediation flow 1 will fetch the financial data from that order by calling the web service of system A, which is responsible for giving the financial data, and then push it to system B. Also, ESB will kickstart another flow, and the second flow will again call system A's, but this time a different web service. This time it will call a web service which will give the customer information related details of that order, and then push it to system C. So you see, by making system A publish an event about the availability of some information, it makes the system more seamless. And in future, I can add more and more target system by adding more and more mediation flows subscribing to this event. So one event publisher and two subscribers of this event. Okay, moving on. The next question is from Rahul, and the question is there a sequence for primitives in mediation flow? Well, there is no defined sequence that you have to follow. Mediation, you typically get a palette, and you get lots of mediations, lots of primitives there for you to pick and choose, depending upon your requirements. For example, you get an encrypted message, which you are supposed to decrypt, and then you have to change some value in it. For example, you have to change from true, false to yes, no. Okay, so in that case, what will you do? Will you try to change the value first and then decrypt, or decrypt first and then change the value? But since the incoming message is encrypted, you have to decrypt first and then change the value. So in this case, yes, there is a sequence that you have to follow. You have to first decrypt before you can understand what is there inside the message. But in most of the cases, it's up to the requirement about what has to be there. And it's up to you how you combine those primitives. The tool should not limit you about the sequence of the execution. Okay, the next question is from Raja, and the question is, what would be the impact of public and private clouds on SOI? And our private cloud applications talk to public cloud applications. Well, the cloud applications are a little more than just web services here, and there are other aspects that need to be taken care of in terms of when you're dealing with cloud and non-cloud applications, especially when the cloud applications are within the organization and outside the organization. Yeah. So the core principle of SOI will definitely be used, because of course, there are two systems, one inside, one outside, and they need to be integrated. So rather than using the internal APIs of those applications, it is always advisable to have the service orientation capability added there. And then the additional capabilities that are expected as part of any cloud application will also required, which may or may not be there as part of your standard ESB application. And you may want to check products like WebSphere, Cloudburst appliance, or those kind of things. The next is, what are the ways to add security/request authentication to SOA? How can we protect our SOA system from spam requests? And this question is from Nitin. How do we protect? Okay. Typically, as part of the enterprise service bus framework, you get various primitives which can limit the incoming requests. For example, as part of data power, you get a lot of different primitives that you typically would put in the beginning, and they can look at the content and reject. So, for example, if they see that there is something which is required to be there and it's not there, they can reject. And the data power green box can go, or yellow box, sorry, can go so far as to see if there are repetitive requests coming from the same client. They can consider it as denial of service attack, and after let's say 10 requests in a minute, it can start rejecting the 11th request onward, or it can block that IP address for the duration of 1 hour and notify people about it. Similarly, as part of data power, one of the primitives is for the attachment. It can look at the contents of the attachment, and then it can integrate with one of the enterprise antivirus system and ask for the checking for viruses. And you can decide to strip the attachment and let the message pass, or process the attachment if it is virus free, and so on. So those kind of capabilities are available in advanced enterprise service bus. Next question is, does the ESP has the capability of storing the provider's data, which hits frequently? Okay. This question is from Venkata, and I'm not very sure if I get this question, but if you are asking whether the ESB has the capability to provide some kind of caching mechanism to frequently access data, well, then yes. I mean, it is not one of the standard ESB feature as you would see in the definition of ESB as a design principle, but it's up to the product. And there are products which offer these capabilities. For example, WebSphere Enterprise Service Bus runs on top of IBM's WebSphere Application Server, and WebSphere Application Server has the caching capabilities. So if required, yes, the caching of information can be maintained if we know that this is going to be required very frequently. Okay, the next question is from Nitin again. And the question is, are IBM ESBs and other ESBs like Mule or Apache Camel follow some open standard? How easy it is for a customer to move from one ESB to another? Is there any vendor lock? Okay. Well, the purpose of ESB is to make the end systems interact in a more vendor neutral manner. In other words, irrespective of whether the end system is using Java or .NET or C++, ESB can ensure that it can talk to other systems. But whether ESB themselves are interoperable, no, not entirely. How individual vendors and individual product chooses to implement the ESBs is entirely up to them. But as long as all of them have support for standard technologies like web services, like messaging, JMS, NQ, and they have good adapters with them, like JDBC adapter or the database adapter or the flat file adapter. I believe it's okay to have that kind of ESB as part of the infrastructure. And in terms of vendor lock, if you have, let's say, one ESB from one organization, and if you choose to enhance the platform by adding another ESB from somebody else, it is possible, because the ESBs are supposed to make people talk to each other, and they can very well talk to each other by using one of the common protocols. For example, two ESBs can use a web services protocol to talk to each other, and it is seen very commonly. Sometimes we have a department level enterprise service bus, and then these department level or domain level enterprise service buses interact with the organization level enterprise service bus, and the organization level enterprise service bus interacts with the outsiders like customers and suppliers and vendors and their enterprise service buses. And in these cases, it is not required that all these enterprise service buses are of the same product or from the same vendor. Next question is from Ravi. Can we define multiple mediation flows within an ESB? Of course, an ESB can provide you a placeholder which deploy all the mediation modules, mediation flows, and you can enable, disable, deploy, undeploy. Those things can be done. Okay. Next is question from Ramakrishna. Without ESB, can we send a request to the source? How will be the data validation? Okay. Which format we are interacting, and how the source can understand the format which is sent by the requester. So I think it's similar to the other question. Do I have to use ESB? Can I send this information to the source or target without using the ESB? Of course, in some cases you do that when you don't want to put additional layers in between, like two Java classes need to talk to each other, and they know that nobody else is going to use or reuse that capability. In that case, you don't have to. But in that case, one application has to know the ways to interact with the other application. And without ESB, there could be some gaps between the two, which may not be easily bridged. There's a question from Thiru, and the question is on slide number 18. Why do we need a scheduler? Scheduled interval? Because it's web service. It should be happen on an online manner. Kindly clarify. Well, although it's a web service, but somebody has to call that web service. It is not going to call by itself. So in this case, the requirement was like that. The requirement was that every day 9 o'clock, data has to go from A to B. Since application A, in that example, did not have any kind of scheduling capability, which could be the scenario in your case. I mean, in your case, your application, or the target application or the source application might have the scheduling capabilities. And in that case, it is not required to use an external scheduler. But the scenarios where source and target systems don't have schedulers, the ESB can provide you one, depending upon whether your ESB product has the scheduler in it or not. Okay, the next question is from Chetan Sethi. The question is, I have a doubt, and how will we determine which target has to be called? If we are calling all the targets in the service lookup scenario, then is it not an overhead of calling all together to identify, please clarify? Okay, so I guess the question is that if we are using service lookup, then in that kind of scenario, should we not just call one targets? And what are the scenarios where we would want to call more than one target? And if we do that, then would there be an overhead? It all depends on the requirement. In some cases, I have to choose one of the systems. For example, in January and February, go to server A, and in other months, go to server B. In some cases, I would say, depending upon the customer profile, go to service A, otherwise go to service B. And in those cases, most of the cases, the signature of both the targets are same. So as a when I try to invoke, I'm actually neutral because I use the same interface. Will that be an overhead? Well, if that is the requirement, if both the systems need to know the information, then I guess, well, we may not call it an overhead because then it's a necessity. Next question is, can you let us know some more details on the transport level security, HTTP versus HTTPS? Would ESB handle it internally? Okay, so like I said, ESB provides you and this question is from Dinesh. Like I said, the ESB provides the framework, and then you have to define the mediation flows. And as part of mediation flow, you can define the endpoints towards the source and the endpoints towards the target. So if information has to go from A to B, A says I support HTTPS. So the endpoint facing A that you configure in your enterprise service desk, you have to define the HTTPS, or you have to enable SSL there, or you have to specify which certificate to use when invoking the service of A. And when you define the endpoints facing B, there you don't have to enable SSL. So you receive the request over HTTP, but when you send it to A, the provider, you enable SSL and provide it over HTTPS. So yes, most ESBs have this capability to handle it, and you should be able to do that by using appropriate mediation flow capability. The next question is from Balaji. The question is, you mentioned in authentication and authorization that LDAP credentials. Can you elaborate on it? What is the LDAP and how the gap will be filled? Okay, what is LDAP? That's a big topic, to cover as an answer to one of the questions. But LDAP typically, is used for storing user credentials. For example, user ID, password, their email ID, and so on. And in an organization, if there are multiple employees, they would have their credentials stored in LDAP, and then they can log into various systems and provide their credentials. And sometimes the applications use these credentials to go out and call other applications, because in sometimes other applications also these credentials are expected. For example, if I'm from the finance domain and if I try to call a service of HR domain, it should not be allowed. And how will system protect it? Only when it knows that the request is coming from somebody from finance domain. So the credentials of the user and whether they belong to the finance department or the HR department is important. And by typically most of the ESBs can integrate with LDAP solutions. IBM has Tableau, Active Directory system, effectively directory server, which is the LDAP server, and website ESB and message broker and data power. All three can integrate with the TDS or the other LDAP system like Microsoft's Active Directory. And once it knows that it has to integrate with LDAP, for incoming calls, it can extract the credentials of the request and do a lookup in LDAP and find out more information about the caller. It can find out whether the caller is from finance department or from HR department, and based on that either decide themselves within the ESB or let the target system decide whether it wants to serve the request or not. Okay, the next question is from Smita. The question is, if an ESB work in distributed computing technology, does it support real-time monitoring and tracing and logging of events? Okay, well, for real-time monitoring, I'll have to give you an example. There's a product from IBM called WebSphere IIC, Integrated Information System, where there's an adapter which can interact with the control systems in manufacturing domain. And these control systems, depending upon the change of status in, let's say, a valve or a tank or a heater or a chimney, can feed the information about the pressure or let's say the temperature to the adapter, and the adapter can provide this information to the enterprise service bus. Yes, so by using the right set of adapter, we can make the ESB know about the real-time events and do the logging of these events. And like we said, the events can be handled in ESB, and then ESB can have people subscribing to these events. So when these real-time things happen, ESB can monitor by using a proper adapter and provide the information to the relevant set of subscribers. Okay, next question. There's a long question from Crystal. Question is, who is the owner of the contracts in or interfaces in case of publish / subscribe and request reply? Is it always the provider that owns the contract? But in that case, what about the reply contract in a request reply scenario? And second question is on slide 13, push with data. How to send response from the consumers in case of publications, and how to handle the responses as a provider when working with publications. Okay. So there are two questions actually. The first is, who is responsible for defining contracts or defining interfaces? So again, information has to go from A to B. A is the provider, B is the consumer. Who is responsible for defining interface? So let's say if I'm exposing web service, who is responsible for defining the WSDL? Well, the answer of that question is both of them. The WSDL has to be defined when both of them sit together and work on the contract. It is the contract where provider says that, yes, I agree, I will give you this information. And consumer says, yes, I agree that when I ask you this information, I will give you these input parameters. So I will give you address, and you tell me whether this address is valid or not. So these contracts cannot, or these interfaces cannot be defined in isolation. Ideally should not be defined in isolation. And if you know your consumers, then yes, you should define in consultation with them. In some cases, you don't know all the consumers. You know that you are developing something which sounds reusable, but you don't know who all are going to reuse. Well, in that case, you have to use your judgment and try to define the interface in a more generic way, and think of people who may not know everything about your technology. Try to make it more technology independent and platform neutral. And the second part of the question is about the responses. But responses are not always mandatory. Sometimes it's just a one-way push. For example, application A has something important. It has the data which it wants to share with others. It can just put this data in a queue, and that's it, and be done with it. So this is more like a one-way, fire and forget kind of thing. Data is in the queue, and people who are interested can subscribe to that queue and get the information. When I say Q, it could be keyword topic. People who are interested can get the information from the keyword topic. And the ESB framework, most of the ESB framework can interact with the messaging-based systems. Okay. The next question. Yeah. The next question is, how do we propagate user identity in case of ESB as exposed at a JMS binding? Well, the question is from Ashley. If it is exposed as JMS binding has the JMS headers, and as part of JMS headers, we can provide the information about the user identity. The next is from Shampa. HTTP over HTTPS, SOAP web, and SOAP over JMS calls can also be implemented using EAI too. Then how SOA and SOI different from EAI? Well, EAI and SOI are not two completely different, distinct technologies. These are the best practices, and actually SOI is the evolution of the best practices that you use in EAI. In other words, if you are using EAI, you may call it EAI, but if you're using all the best practices of service-oriented architecture, and you are using the web services which are good services, as per the standards or the specification of the service, then you are actually using SOI. Next question is from Pankaj. Virtual servers where the no voice or who are trying to expedite the SOA or SOI can do a POC sort of thing before actually start implementing. Well, Pankaj, for that, I would recommend you contact Pavan. His email ID is given in the last slides, and he can help you with that. Okay, next is from Harish. Can you provide a price comparison with different ESBs like OSB and WebSphere ESB? I guess Oracle Enterprise Service Plus and IBM WebSphere Enterprise Service. Okay. The price comparison. Well, again, I mean, you will have to contact Pavan for those details. And he may not even know about the Oracle Enterprise Service Plus. He can help you with IBM's different ESBs like WebSphere Enterprise Service Plus or Message Broker or Data Power, and the different editions of these products. The next question is from Nagendra. The question is ESB product specific to a particular language conversion or the protocol conversion? Well, the beauty of the ESB is that it's supposed to do the conversion from multiple languages and multiple protocols. So yeah, a good ESB should not be limiting itself to just one programming language or one technology protocol. It should support multiple. Okay, there is a question from YSK Nathan. The question is scenario like ERP, we require speed, improved response. Does the SOA working as web service provide the capability? Well, web services not necessarily need to be that slow as they are perceived to be. With systems like Data Power, they could be lightning fast. And we don't always have to use web services. Like I said, if you are following all the best practices, it doesn't have to be web service. If you want a faster option, you can go for the RESTful interfaces for the implementation of our ERP interfaces. The next question is from Ravindra. The question is SOA mean giving output data as needed by the client/customer, and SOI is integrating different applications to give required output to client/customer? Again, I'm not very clear about the question, but I guess if you're trying to ask if it is the responsibility of SOA to give output, I guess you're trying to ask what is the difference between SOA and SOI. Okay. So SOA is a generic, architecture and practices, and SOI is using those practices especially for integration. Okay, and things like ESB and a good service concept, they're all SOA concepts. Okay, so these are not two different things. SOI is basically using service-oriented architecture for integration. The next question is ESB has any dependency on type of web service that source or target use like JAX, RPC, or RESTful web service? This question is from Rajesh. Well, a good ESB should support all of these. It should support RESTful interfaces, it should support JAX RPC, or it should support the non-RPC web services also. So ESB as a concept is independent of it, and depending upon the product that you are using, you should have all these capabilities in it. Next question is from Suman. The question is does SOA support authentication and authorization services, and which authentication way is the best one for SOA? Well, the answer is yes. Do they support authentication and authorization? But the objective of this session was more towards the integration, not the generic SOA. SOA can be used for application development also, which may not have much to do with integration. But here we are focusing on the integration, and in the integration context, yes, authentication and authorization capabilities are required, because sometimes the service that we're trying to call, or the provider of the information, is protected, is secure, and to get to the information in that target system, we have to go through the authentication and authorization. So authentication is like providing the correct credentials, and authorization is whether that user has the rights to access the service. And as part of my mediation flow, some of the ESBs offer the capabilities where I can enable who should be allowed to access the service exposed by the source system or not. So yes, it can be done. For example, data part can do that in the tool itself, or it can integrate with some other security systems, like some other privilege systems which provide other capabilities of authentication and authorization. Okay, the next question is SOI modular? Can we pick and choose what we need and leave the rest? This question is from Selvin. So if you are trying to ask whether you choose some of the best practices and decide not to use the remaining best practices, well, I would recommend the best practices part. However, in terms of products, yes, you have a choice. There are some ESB which will be comparatively economical, which will have less features. So yes, you can do that. And there will be some bigger ESB products which will have more features and a little more expensive. So there you have a choice. You can choose which features are most critical for you, and go for an ESB which provides only those capabilities. Next question is how an application deployed in the TIBCO works differently on WebSphere, and this question is from Neha. Well, if you are talking about the TIBCO web service and the WebSphere enterprise service bus mediation flow, then well, conceptually there should not be too many gaps, because TIBCO's enterprise service bus also has a similar concept. I have never worked on TIBCO's enterprise service bus, but I'm assuming they also have this concept of mediation flows and primitives. They may not call it mediation flow, they may not use the word primitives, but that's what most of these enterprise service bus are designed on. Okay, the next question is EAI can implement all the solutions that ESB can handle, and what is the difference? This question is from Sandeep Kumar. So like I said earlier, these are not two different, completely distinct techniques. ESB or SOI is an evolution of the traditional EAI. And there was a chart where we saw that in a traditional EAI, we use adapters, and we use the mechanism and the ways to interact with the source and target systems, which are not always based on the open standards. For example, it is very common to use the internal APIs of the system to make it interact with the broker or the hub in EAI. And it is very common to have the EAI brokers provide the proprietary protocol to make applications interact with them. However, if your EAI product has web services capabilities and you follow all the standard practices, as part of it, all the good practices which SOI expects, then yes, you can use your EAI to implement the SOI. It's about the best practices. It's about using the right approach and making your application more loosely coupled. The question is from Anupam. Anupam, by adopting ESP bridge as a middleware, the architecture remains typical 3-tier, correct or incorrect? Well, the 3-tier architecture, typically we would use system, where we have the display logic, and then we have the application, and then we have the database in the backend. Well, and ESB is part of middleware. So, well, the middleware, is there in the middle of both the client and the database. So yeah, it just extends your existing middleware, and it doesn't add a new tier to it, if that is what you're trying to ask. So the next question is from Ajay. What is the difference between ESB and WMV in terms of integrating SOI? So if you're asking what is the difference between the IBM's WebSphere Enterprise Service Bus and IBM's WebSphere Message Broker, WebSphere Enterprise Service Bus is based on the J2EE platform. So it has a core of it is WebSphere Application Server. So if you have more skills in the WebSphere Application Server, and if you have already WebSphere Application Server based the platform, and if you are expert in Java and J2EE concepts, and you're happy with the security and the high availability and the load balancing features that the WebSphere Application Server provides, then ESP is a very good example option for you, because then most of the skills at the infra level are already there with you. However, if you want the higher volume of message processing and the extensive messaging driven integration, then WMV would be more appropriate for you. The next question is, how can we differentiate between a BPM flow and the message flow in ESB? This question is from Ravi Teja. BPM flow, I think in the second last slide we mentioned briefly that once you have the services, you can define more complex flows and go beyond the enterprise service bus and do something like business process execution language and define the flow of it. And using this BPM flow, you can do the orchestration or the choreography of your services. And there you can have much more additional capabilities. For example, you can have the human task feature, like we discussed. In case of any error, let a user take a look at it before proceeding. Or you can have a rollback kind of features, which is more of compensation capabilities as part of the detailed framework. However, most of the business process flows work on the payload part, and they are, their purpose is not to work on the header, which is the technology header, in terms of the GMS header or the HTTP header. So the technology level, changes and manipulation and exchange is expected to happen in ESB, whereas the information exchange of the functional data can also happen as part of the BPM flow. BPM also provides, the stateful or the long-running business process capability, where the state can be persisted, whereas typically ESB flows are stateless. So information has to flow in one go from A to B. And I think that is all from the list of questions.
Yeah.
So looks like we are done. Well, once again, thank you all of you for joining, and thank you for asking all these interesting questions.
Yeah, there are
and
few other questions.
There will be a recording of. There are
a few other questions, but we can take them offline. We have already overshot by 45 minutes. So other questions can be taken offline.
Okay. All right. I guess this presentation will be available on the TechGig website, where you can just go and replay it if you want, and with a link to the YouTube. So if you have any questions, you can send your questions to the TechGig website, and we should be able to handle them. If you have more questions in terms of IBM services and offerings, you can contact Pawan at the email address given on the last slide of the deck. Thank you once again. Bye-bye.
Thanks, Mr. Tapan, for your informative session on service-oriented integration, approaches and best practices. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgig.com by tomorrow. Gentlemen, the next session in TechGig webinars is happening on Monday, that is 12 March at 3 p.m. Topic for the webinar is first in the Tech Leadership Series, and it goes Success through Self-Development and Innovative Approach. We will be having Mr. Shantanu Paknikar, General Manager, Solution Initiative at Happy Minds Technologies Private Limited as our guest speaker. So see you all on Monday at 3 p.m. Thank you.